Alright, so girls, last lesson we looked at vertical and horizontal translation, which is all about shifting the graph up or down or sideways, okay? Today we're going to be looking at vertical and horizontal dilation, and dilation is when you have a graph that either becomes narrower or wider, okay? So let's have a look at vertical dilation to start off with. So we know y equals to x squared is just a regular parabola like that, where it goes through 1 and 1, okay? And from last term we learned if the number in front of x squared gets bigger, so let's say in this case 4, the parabola gets narrower, right? Okay. Now just to be more specific, let's substitute x equals to 1 to see what y value we get so we can more accurately represent the narrower graph. So obviously if I substitute 1 in here, the y value is just going to be 4. So that means it's going to go through 1 and then 4. 3, 4. Let's just say it's here. So it's going to go through here, 1 and 4. So this would be the parabola if there was a 4 in front. Okay? So I'm just going to stop here for a second to introduce you to some new terminology. Okay? So when the number outside of a function, so in this case x squared is the function, the number outside of it, that's 4, that's called a scale factor. Okay? And if that factor is bigger than 1, okay, k represents the factor. If that number is bigger than 1, the graph is vertically stretched. What vertically stretched means is vertically means y values and stretched means it's increased. So as we can see from 1, when we put 4 in front, the y value from 1 has increased to 4. Okay, so that's what vertically stretched means. But visually the graph has become narrower by a factor of k, in this case by a factor of 4. Alright? Now, if the number in front of the function or the scale factor is less than 1 but bigger than 0, so in other words between 0 and 1, the graph will become vertically compressed, which means the y values are decreased. So for example, likewise, if I substitute x equals to 1 in here, the y value is going to be 1 over 4. So let's plot that out. So 1 and 1 over 4, let's say that's 0.25. That. Okay, as you can see, it's wider. Okay, so yeah, that's what it means by vertically compressed. As you can see, the y value is 0.25. It's gone smaller. All right. So let me just label what we've learned here. So this blue line is when it's vertically. Okay. Right. So that's vertical dilation, and it's also called dilation from the x-axis, okay? Because as you can see, from the x-axis, the blue parabola is a lot further from the x-axis than the red parabola, okay? So any vertical dilation, it's called dilation from the x-axis, not y-axis, okay? So don't be confused, all right? Now, that's okay. Horizontal dilation though, it can be a bit confusing when we compare it to vertical dilation, so I do want to make this clear. Let's have a look at horizontal. So once again, I'm going to start off by drawing y equals x squared, which is a regular parabola. What you'll notice with this one though, instead of y equals to 4x squared, the 4x is both inside a bracket squared. Okay? Now, you know how I substituted x equals to 1 to find out the y value? In this instance, I'm going to do the opposite, and I'm going to substitute y equals to 1 and see what the x value is from there. So if I substitute 1 in here, I get this, and I'm going to solve for x here. So if I square root 1, that's plus or minus 1 equals to 4x. So that means x is equal to plus or minus 1 over 4. So that means in this graph, it has to go through plus or minus 1 over 4 and 1. Okay, let's see what the graph looks like. So a quarter is my new x value. Let's say a quarter is there and it has to go through 1. So my new graph is actually very, very narrow. Okay, let me just label the point, quarter and 1. Okay, so that's some horizontal dilation. When the scale factor inside the function, so notice the scale factor is now inside the bracket. If it's bigger than 1, okay, that means the same thing. A represents the scale factor. The graph is horizontally compressed. So what that means is the x values are decreased. And as you can see, from 1, it has decreased to a quarter. Okay, okay, it still makes the graph narrower, okay, but it becomes horizontally compressed, okay? That's what I wanted to point out. Now, it becomes narrower by a factor of 1 over a. The reason why it's 1 over a is notice how the x value from my original parabola was 1, but when I had a number 4 in front, inside the bracket, it now goes through 1 over 4, okay? That's why the reason is 1 over a, okay? So the number in front of x is your a, so 1 over a in this case is 1 over 4, as you can see through that calculation. That's the reason why, okay? So that's what I wanted to show. When it's vertically dilated, you're simply just multiplying the y value by whatever number's in front, so that's how we got to 4. But with horizontal dilation, you gotta get the number in front of x, put it under 1, which represents the x value that has changed, not the y value compared to that. Okay, so I wanted to make that clear. Okay, now, same thing. If the scale factor is now between 0 and 1, the graph is horizontally stretched, which means the x values are going to be increased. Let's find out why. So once again, let's substitute y equals to 1 and see what x value I get from there. So 1 is equal to a quarter that squared. Square rooting that, I get plus or minus 1 is equal to a quarter x. That means x is equal to plus or minus 4 if I just times the 4 across. So that means my new parabola for this, it has to go through plus or minus 4 and 1, okay? So let's label that. So let's say 2, 3, 4. Let's say 4 is there and 1 is there. So this is my new graph. So as you can see, it looks a lot wider, okay? So just like what we had there, it gets wider, but the x values are increased, okay? So from 1, the x value is now gone up to 4, okay? By a factor of 1 over x, same thing, because in this case, it's 1 over, the number in front of x is 1 over 4. 1 over 1 over 4 is 4, okay? And as you can see, that's what I had here. So that's what I wanted to point out. Let me label everything here. So, okay? So this is what I wanted to clarify. Have a look, okay? When the number in front of x is bigger, okay, they both become narrower, okay? But it's called vertically stretched in this situation, but in this situation, it's called horizontally compressed, okay? That can be a bit confusing, and that's the reason why, which I've explained previously, okay? So I want you to just compare the both. When it gets wider for vertical dilation, it becomes vertically compressed, but in horizontal dilation, it becomes horizontally stretched, okay? So that's the mix-up that a lot of students might have. But yeah, the terminologies are different for different situations, these two cases, okay? So, one more thing, yeah, horizontal dilation, it's also called dilation from the y-axis, because if you compare these two graphs from the y-axis, as you can see, the parabola from the y-axis, it's a lot closer, whereas with the red parabola from the y-axis, it's a lot wider, okay? So with horizontal dilation, you're comparing the graph from the y-axis, whereas from vertical dilation, you're comparing the graph size away from the x-axis, okay? So yeah, as you can see, there are a lot of different terms here, which seems like a mix-up. So now let's apply this to a couple of questions in your exercises, okay? So exercise 203 is vertical dilation, which is the easier one, okay? 1E, okay? Describe how the constant, okay? That means the scale factor in this case, affects the transformed graph given the parent function and state the scale factor. Okay, so question 1E, we've got absolute of x, and then from here, we've got that, okay? So like I've discussed, if there's a number outside of the function, that's vertical dilation, okay? Now to be more specific, if the number is bigger than 1, it's vertically dilated, or to be more specific, you can say it's stretched, okay, by factor of 5, okay? In the answers, they usually just say vertically dilated, okay? That's the answer. Let's have a look at the second part. If it's now over 8, okay, that means compressed because the scale factor by factor of 1 over 8. Yeah, because this is 1 over 8. All right. Now the third part, it's a bit different to what I've been doing, but you've learned this last term. If it's just got minus in front, so if you have a minus in front, it just means it's being reflected in the x-axis. Okay, so it's just being flipped upside down. That's all it means. Okay. Let's have a look at question 2D. Find the equation of a transform graph, state its domain and range. Question 2D. So if f of x has been dilated to with a scale factor of 4, that just means vertically. So that's just all you need to do. Okay. So what you'll need to do is just sketch that and find the domain and range. All right, that's not hard. Let's have a look at 6a. Sketch log 2x and then 2 log 2x. Right. So let's sketch. With any log graphs, despite what base it might have, it's always going to go through 1. Okay. And the y-axis is always going to be the asymptote. Okay. Now, in front of that, if you have a 2, that just means you're multiplying all the y values by 2. So really all you need to do is draw something like this. Okay. So as you can see, you just need to show that distance has been now doubled with the new one. Okay. As you can see, like that distance is twice that distance. So that's kind of what you need to show if you have the number in front. Okay. Now question 8, I just want to give you a guide in case you forgot how to sketch this. So if you have x squared inside a square root, that's a semicircle. Okay, so what you want to do is factorize what's inside. Yeah, using difference of 2 squares. So it's going to go through 1 and minus 1. Okay, and because it's just a positive, if you had positive and negative, it will be the top and the bottom. But because if it's just square root, it means it's just going to be on the top. It's meant to be a nice semicircle there. And it's going to go through 1. Yeah? Because if you substitute x equals to 0 here, y equals to 1. So as you can see, it's a semicircle. Okay? Now, from here, if you wanted to draw twice of that, okay, you just need to times 1 by 2. And then you're just drawing the same thing, but an odd-looking semicircle. Okay? Alright, so that's vertical dilation. Let's have a look at horizontal dilation now. Question 2. Describe whether the constant describes a horizontal vertical dilation and state the scale factor. Alright, question 2ci. So let's just write the original equation. We've got x to the power 4. For the first one, it says bracket 7x to the power 4. If everything is inside the bracket, as we learned from the previous side of the board, it's horizontal dilation. Okay, and that's all you need to say. But if you want it to be more specific, right? If the number is bigger than 1, it's going to be narrower, which means the x values have been compressed. Remember, the smaller the x value becomes, the more narrower it becomes from the previous side of the board. Okay, by factor of, remember, 1 over the number in front. Okay, so that's the difference between vertical and horizontal. You just put the number under 1 for horizontal. Second part, if it's just got this, okay, there's no bracket. This is like that. It's vertically dilated because it's not inside a bracket. Vertically dilated, but once again, if you want to be more specific, it'll be compressed because it's a smaller number than 1. Okay? And because it's vertically dilated, it would just be a factor of whatever number is in front. Okay? No need to put it under 1 because it's vertical. Third part, it is inside the bracket. 1 over 3 over 4 is just a reciprocal, 4 over 3. Okay, so that's how you read horizontal dilation. Let's move on to question 3 now. Find the equation now this time and state the domain and range. So my f of x is absolute of x, and it's been dilated horizontally with a scale factor of 1 over 5. Okay, so scale factor is 1 over 5. The opposite of 1 over 5, or reciprocal of that, is just 5. that's what you would put inside the absolute sign, because if it's horizontal, everything's inside. Yep, so that'll be it. And then you would have to sketch that to find domain and range, which I will get you girls to do. 3b, so that means I need to put inside a bracket like that, leaving the squared outside. If it's scale factor of 3, that means I have to put 1 over 3 inside the bracket. Okay, so ln x is log ex. And once again, remember, it doesn't matter what base it is, it's always going to go through 1 with that shape, and that as the asymptote. But this time, I have 2x inside. So if I have log e bracket 2x, okay? Let's think about this, right? If there's a number in front of x, that means it's going to get narrower. If it gets narrower, that means the x values are compressed. So by that much. So we're getting all the x values and then halving it. That's how you want to think about it. So instead of 1, it's going to go through a half. All right? So you're drawing a narrow graph that goes through half. Okay? So basically every x value on these gets halved. Okay? So that's why you get something like that. Okay? Not the most accurate graph, but you just need to show that it goes through half at least. All right? Question 9, I'll finish off with that one because I thought that was a bit tricky. It says sketch the graph, so I'll do it here. Y equals to f of ax. Sketch that if your a value is a half. So sketch half x, okay? So if the number inside is smaller than 1, if it's smaller than 1, it's going to get wider. That means the x values are going to be bigger by multiplying by 2. Okay, so what you need to do is get those dot points and times each of those dot x values by 2 and then join them up and you'll get the graph. Okay, that's all I wanted to show. Okay, girls, that's basically what I wanted to show. Give all of those questions a go and let me know if you have any questions. Thanks.